For almost as long as man has been building shelters, the most favoured flooring material has been timber, due to its comfort and practicality. Over the centuries, these features, together with the warmth, versatility and timeless beauty that timber offers, continue to make timber the #1 choice for flooring in today's modern architecture. To ensure that we obtain optimum performance from a timber floor, the natural properties of timber need to be kept in mind during building design, construction and the flooring installation. This has become even more significant in recent times with the growing trend to install timber floors over concrete slabs and other existing surfaces commonly encountered in renovation work. What is perhaps most important to obtaining optimum performance is the understanding that timber is hygroscopic. That is, it takes up and gives out moisture, and in the process of doing so, it undergoes small dimensional changes. To provide detailed recommendations for timber flooring, the timber industry has recently completed extensive field research and testing programs aimed at more accurately identifying the effects of humidity and geographical location on timber's hygroscopic nature. Studies were carried out on many sites, as diverse as far north Queensland and southern Victoria. The results of these studies have culminated in the recent release of a series of new data sheets, which will form the basis of national standards for the design and installation of timber floors throughout Australia. Visit the website for copies of the new flooring data sheets, as well as other valuable information on timber products. The data sheets deal with 1. General characteristics of tongue and groove timber flooring and floor finishes. 2. Requirements prior to installation. 3. Recommended installation procedures. And 4. Sanding and finishing. Let's look at important aspects to consider when choosing a tongue and groove timber floor and the floor finish that will be applied. Basically, there are 3 factors influencing the choice of a suitable timber for a new floor. Firstly, colour preferences will generally influence the species or the species mix chosen. Secondly, natural features influence the character of the floor, and these are controlled by the grade. Within limits, different grades allow or exclude certain natural features of the timber, such as gum veins and knots, thereby substantially influencing the appearance character. Manufacturers often specify their own grades that differ from those in the Australian standards. Finally, a hardness suitable for the area of use is important. That's supposed to be lucky, isn't it? This table sets out details of timber properties for the most readily available species generally specified for timber flooring. For example, from the table we can see that Tasmanian oak has a colour which is pale straw to light brown and is classified as moderately hard. This section of Datasheet 1 also deals with cover widths, standard board thicknesses and profiles, and also includes an ordering checklist together with a suggested method to determine the lineal metres of flooring needed. At an early stage, it's also important to consider the floor finish that will be applied. Datasheet 1 provides information on the different types of finish available and the properties of each. Board cover width, the climate within the house and the anticipated amount of wear on the floor will all influence the choice of finish. But we'll talk more about this a little later when we discuss the application of finishes. Now that we've chosen the right timber for our application, we need to look at pre-installation requirements. It's all covered in Datasheet 2. Flooring should be delivered on-site with a protective wrapping to assist in maintaining the appropriate moisture content. Once on-site, it should be placed under permanent cover or another equally effective storage to prevent moisture uptake and excessive sun exposure. This is one of the areas where recent research has provided a much better understanding of the correlation between geographical location, natural humidity and moisture content. The moisture content of timber flooring will vary with changes in humidity and temperature of the surrounding air. To minimise swelling and shrinkage of a timber floor, it's important to fix the flooring in a state which reflects, as closely as possible, the in-service environment. This will vary depending on geographical location and particular site conditions. If the moisture content of the flooring is not closely aligned to the expected in-service conditions, acclimatisation on site may be beneficial, or in some cases additional expansion allowance like these small joints every 800 millimetres may need to be provided in the floor at the time of installation. It's important to realise that acclimatisation is not mandatory, and if undertaken in the wrong conditions, it may worsen the final appearance of a floor. Datasheet 2 also closely examines the requirements for evaluating site conditions. For example, it highlights the likely moisture differences between elevated building sites and those in bushy gullies. It also looks at the different characteristics of closed-in and open subfloor designs and draws attention to specific considerations related to each. It looks at the effects of intense sunlight through large windows and the effects of heating or cooling systems. Now this is important. Datasheet 2 highlights the fact that if due to nothing other than naturally occurring humidity fluctuations, small gaps between boards can be expected to appear and then reduce in size with seasonal changes. A simple flow-through guide to pre-installation conditions appears in Figure 2D. Datasheet 3 looks at installation and its close relation, ventilation. When it comes to installation, probably the most common application of all is tongue and groove timber strip flooring over timber joists. And one of the most important considerations when designing for timber floors is to ensure adequate and proper subfloor ventilation. The humidity in an enclosed subfloor space can have a profound effect on the performance of a timber floor. While ventilation recommendations in the Building Code of Australia may be suitable for durability aspects of timber floor framing, recent research has identified that they are not considered sufficient for timber flooring. Datasheet 3 covers the latest revisions. The recommended minimum subfloor ventilation for T&G timber floors is now 7,500 square millimetres per metre of wall, with vents spaced evenly to ensure that cross-ventilation is provided to all subfloor areas. That equates to about half a house brick of clear space for every metre of wall length. The drainage system provided around the dwelling site should ensure that all surface water will drain away from the perimeter of the building. The subfloor space must be dry and remain dry. It should be well graded to ensure good runoff and no ponding. While Australian Standard AS 1684 contains appropriate detail on sizes and spans for the supporting timber structure, Datasheet 3 updates recommendations on joist and flooring thicknesses and flooring spans. Where end-matched flooring will be used, that is, where a tongue and groove joint is provided at the ends of boards, joists with a minimum thickness of 35 millimetres are suitable. Where plain end flooring will be butt-joined over joists, a minimum joist thickness of 45 millimetres is recommended to reduce the possibility of splitting to the ends of the flooring boards. For structural performance, Table 3B clearly sets out the minimum recommendations for flooring thicknesses and spans. Where a timber floor is to be sanded and clear finished as a feature, fitted floor construction must be adopted. With this method, the flooring is installed after the roof and wall claddings are in place and the building has been made watertight. This is distinctly different to platform construction, where the floor is laid before the walls and roof structure in order to provide a working platform. When laying flooring, boards should be in straight and parallel lines. Butt-joined boards should be cut to join over floor joists, and joins in adjacent boards should be staggered. It's essential that the undersides of boards are in full face contact with the joist at the time of nailing. Boards should be cramped together prior to nailing. However, it is recommended that not more than 800 millimetres of flooring width be cramped at any one time. Cramping should be sufficient to just bring the edges of adjoining boards together. Fitted floors require a 10mm expansion gap between the boards and any surrounding wall structure, while floors over 6 metres wide should also be provided with intermediate expansion joints. One large joint every 6 metres or smaller gaps every 800mm are two suitable options which are detailed here in Figure 3C. Size and frequency of nail fixings are important and recommendations are covered here in Table 3D. As part of the popular trend in renovation, timber strip flooring can be laid successfully over existing strip flooring or sheet flooring. Where the existing floor is structurally sound, an overlay timber floor as thin as 11mm is sufficient, or standard 19mm flooring may also be used. It is necessary to ensure that the moisture content of the older floor is similar to that of the new material. Datasheet 3 outlines recommendations for fixing onto the existing subflooring and for fixing through the existing subfloor into the original floor joists. The recommendations include references to frequency of fixings, fixing sizes, and again cover expansion joint requirements. With the ever-increasing trend toward natural timber flooring, many applications now see an installation over concrete slabs. Now, this can be achieved successfully in one of three ways: incorporating fixing battens, using a plywood underlay, or fixing directly to the slab. Fixing direct to a slab, however, is a specialised field and appropriate professional fixers should be engaged. So, we'll look at the other two alternatives of using battens or plywood. First, it's essential to ensure that the original concrete slab is sufficiently level to provide a satisfactory result. The concrete slab must have an under-slab moisture barrier and have cured to a moisture content of less than 5.5%. Now, this generally means a slab at least 4 to 6 months old. As an added protection, a polythene membrane over the slab is recommended. Where battens are used, 19mm structural T&G flooring is required. Where plywood is used, an overlay timber flooring, again as thin as 11mm, can be utilised. Datasheet 3 contains comprehensive details for fixing both batten and plywood subfloors to the concrete slab. Once again, these recommendations include sizes and frequencies of the fixing options as shown here in Tables 3F and 3H. Prior to sanding, the condition of the floor should be assessed to ensure that it's suitable for sanding. Datasheet 4 highlights many of the areas to be assessed, such as vertical movement at joints, cupping and moisture content. Before the sanding process begins, ensure all nails are well punched, generally around 3mm below the surface, and that the punched holes are then completely filled with an appropriate filler. Next, ensure that the entire surface is totally clean and free from all dirt and grit particles. This is best achieved with a vacuum cleaning, paying particular attention to areas under skirtings and in corners. Now for the all-important sanding. This process is essentially the abrading of the surface of the boards in stages, commencing with a coarse sandpaper and finishing with a fine. The level or basic coarse sanding removes ridges and high points to provide a level, completely sanded or abraded surface, and each subsequent sanding procedure is designed to finally remove all of the sanding scratches generated by the first step. The first pass is done at an angle of up to 45 degrees in the direction of the grain. The second pass is then carried out on the opposite diagonal and using a similar grade of paper. The third pass also follows with a similar paper, but this time in the direction of the boards. When the full width of the room is completed, turn the machine and complete the unsanded band against the walls. Note that the sanding drum should never contact the floor unless it is moving forward or backward. Doing so will create a drum mark which may be impossible to remove. Areas which the drum sander will not reach, such as close to the walls and in corners, are completed with an edge sander. Finally, we come to the finishing sanding, perhaps the most critical part of the preparation process. It involves two separate stages of operation. The first stage utilises a finer grade of paper, typically with the F60 to 100 range, and this is carried out in the direction of the boards. The complete surface is once again thoroughly cleaned in preparation for the final stage of the finishing sanding, which is then carried out with a rotary or plate orbital sander using a still finer paper, typically 100 to 150 grade. With sanding now complete, the entire surface is once again thoroughly cleaned in preparation for the application of the coating system, the finishing touch that caps a beautiful job. Most manufacturers produce a range of timber floor finishes which can be grouped into four broad categories: oil-based, composites such as oil-modified urethanes, solvent-borne polyurethanes, and waterborne polyurethanes. Datasheet 1 sets out the general description for each of these, and Table 1E provides a quick tabulated comparison of the properties and advantages of each. The selection of the most suitable type of finish is important, and the details in Table 1E, together with the manufacturer's recommendations and specifications, should be studied comprehensively to guide the final choice. Having decided the best product for our particular application, we then set about applying the finish coating. First, a totally clean surface is imperative, as is the cleaning of adjacent surfaces which could hold dust that might drop during the application of the finish. Tops of windowsills and light switches are typical examples. Ensure the coating product is well mixed, and commence the first coat by cutting in with a brush around perimeter walls and other areas not easily accessible to the main applicator. Use an applicator which matches the coating manufacturer's directions. Often this will be a 6mm mohair roller. Pour the coating into a painter's tray and fill the roller from there. Apply the product to the boards with a smooth action and work in the direction of the grain. The finish should be feathered off at the outer edges to minimise build-up of coating at that point. Ensure to leave a wet edge so that successive sections blend with the previous section without ridging. Continue in this manner until the whole area is complete and you've achieved an even, wet look without any dry patches. After the first coat has dried, check for any cracks or nail holes not properly filled previously and apply a compatible filler fully pushed in and slightly overfilling the void. The floor requires a light sanding after the first coat, and this is typically done with a rotary sander and 150 grit paper. Hand sand edges to a similar finish. It should be noted that this sanding is primarily to remove any roughness in the first coat and to provide a key for the second coat. It's imperative that this sanding is very light and does not expose any timber. Again, thoroughly clean the surface and apply a second coat and any further subsequent coats in a procedure identical to the first. And there we have it, the unmistakable appeal of a properly installed and well-finished timber floor. Visit the website for copies of the new flooring data sheets as well as other valuable information on timber products. Following the design advice and other recommendations contained in this series of data sheets will ensure you achieve a warm, practical and comfortable floor that will provide many years of service.